Today, we're going to be starting a new unit, which is atomic structure. During this unit, we will also be going over nuclear chemistry, radioactive decay, half lives, nuclear reactions. So, some of this will be a review from your earth science class and probably from biology. Some of it will be new. So just just make sure you're, following along, that you're practicing, and if you have any questions, please ask. So I'm starting with kind of a joke, but it says, "Don't trust atoms. They make up everything." And this is true. Atoms do make up everything we see around us. And so, just to review the structure of the atom, there's two regions which we'll be focusing on. The first one is the nucleus. If you remember, the protons and the neutrons are in the nucleus, and sometimes these are referred to as nucleons. They are the particles which make up most of the mass of the atom. The nucleus has a positive charge due to the protons, and like I said, it has almost all the mass. The electron cloud makes up most of the volume of the atom, and it's where we could find the electrons. Okay, so the atom is composed, like I said, of the nucleus, which has the protons and neutrons. Protons are positive. Think about P for positive. Neutrons are neutral. Think of N for neutral. Electrons have a negative charge, and they are obviously in the cloud outside the nucleus. Like I said, the protons and neutrons make up most of the atom's mass, and the atomic number, which we find on our periodic table, equals the number of protons. If we have a neutral atom, that means it has zero charge, the number of protons will equal the number of neutrons. Excuse me, the number of protons will equal the number of electrons. Okay, just to give you an idea about how small an atom is, um, here we have an atom of helium, and the helium atom is about 1 angstrom thick. And just to give you a perspective, when we look at a sheet of paper, it's about 1 million angstroms thick. So you think about, in your thickness of paper, you have about 1 million atoms. So like I said, the mass is mostly made up of neutrons and protons. The electrons are outside in the electron cloud. So the most of the volume of the atom is empty space. And again, to give you some perspective, if you were to go to the Giants football stadium, if you can imagine, in the center of the field, there was a marble, that would be the nucleus. The entire stadium would be the entire volume of the atom. And then if you can imagine, maybe an ant walking on the bleachers would be an electron. So what we see is most of the atom is made up of empty space. So if you can imagine, if you're touching a piece of a table, the atoms in your hand and the atoms in the table are mostly empty space. So the question is, why doesn't our hand go through the table if most of the atom in our hands and in the table are empty space? The reason why our hands don't go through the table is actually because of those electrons. As the atoms in our hand approach the atoms in the table, before the atoms can even touch each other, the electron clouds in our hands and on the table begin to repel each other, and that's what prevents our hand from going through the table. So in reality, you never really touch anything. What you're really feeling is the repulsion of the electrons in your hand and the electrons in the clouds. I mean, the electrons in the atoms of the materials that you're going near. So when we talk about fundamental particles, protons and neutrons, we now realize are not the smallest particles. So we actually have quarks. So if you ever hear about quarks, protons are made up of 2 up quarks and 1 down quark, and neutrons are made up of 1 up quark and 2 down quarks. I don't expect you to know that, but I'm just showing you these are not the smallest particles. And quarks are held together by gluons. So that's what, if you hear about the terms quarks and gluons, that's what those are. Now, the atomic number is referred to as Z, and this is the number of protons in the nucleus of each atom of that element. So, if we look at some common elements, carbon has an atomic number of 6. So, Z is 6. 6 is the number of protons. Phosphorus has 15 protons if you see in your periodic table, so it's Z is 6, and gold has 79. So we could find out the number of protons or the atomic number just by looking at a periodic table. It's pretty easy to figure out. Now, the mass number A is actually not given to us in the periodic table. It's the number of protons and neutrons in the nucleus. So mass number is referring to all the particles that have mass in our atom. So it's the number of protons and neutrons. If we look at oxygen, it has, if we're talking about the isotope that had 8 neutrons, we know from the periodic tables it has 8 protons. If it's, since it's neutral, it will also have 8 electrons. The mass number would be the protons plus the neutrons, and that's going to be 16. If we look at a periodic table, what we will see is that oxygen's mass that's given to us in the periodic table is, on your periodic table, is 15.999. Actually, yours has 16. Some periodic tables will be 15.999. So if we look at arsenic, arsenic has 33 protons. If we're talking about the isotope that has 42 neutrons, it's neutral, so it will have 33 electrons. The mass number will be the sum of the protons and the neutrons. Now, if you look at your periodic table, you will see that arsenic has a mass of 74.92. So this is something we would determine either by rounding our mass from the periodic table or from calculating it based on our protons and neutrons. Here we have phosphorus. It has a number of protons of 15. Since we know we're being told that it has a mass number of 31, this would tell us that we have 15 electrons and 16 neutrons. Okay, so when we're looking at our periodic table, to determine the mass number using our periodic table, we're going to be rounding the mass number from our periodic table. So actually, let me pull up your periodic table and let's look at it. Okay, so let's look at, chlorine. Here's chlorine. So we know that chlorine has an atomic number, or Z, is equal to 17. Its mass, we're going to round that to get the mass number, is going to be 35. So we know that chlorine will have 17 protons, 17 electrons, because we're assuming that it's neutral. And to figure out the number of neutrons, we're going to take 35 and subtract 17. That's going to give us 18 neutrons. So we could never have part of a neutron, just like we could never have part of a student. So when we're talking about the mass number, we're going to be using the rounded number. This will allow us to get a whole number of neutrons. If we were to use the mass from the periodic table as is, we might end up getting a partial number of neutrons, which isn't possible. Likewise, if we look at copper, so let's go down a little bit. Here we have copper. Okay, so copper has an atomic number, or a Z, of 29. It has a mass number, A, is 64. And then we're going to calculate the number of protons. It's going to be 29. Electrons is also 29. Neutrons is going to be 64 minus 29, which will be 35. So when you're rounding these to get a whole number for your mass number, look at the number that's after your decimal. If it's 5 or greater, you round up. If it's less than 5, you keep it the same. So we're just paying attention to that number directly after the decimal. You do not double round. Okay, so let's go back. Okay, so before we go on to ions, I want you just to practice with determining your protons, neutrons, and electrons for neutral atoms using your periodic table and using the worksheet that's on Google Classroom. Okay, so I want to go over now the ions. So I first want to go over what ions are. These are atoms that have a charge. They form when either you have atoms that lose electrons or atoms that gain electrons. You never, ever, ever change the number of protons. If you were to do that, you would get a totally different element. So let me just write that in. So never change number of protons. Okay, so the reason why I have a cat and ant on this slide is a way to remember that that ions that are positive are called cations, is to think about if you remember when you were a kid and you were drawing a cat, you might have put a plus sign for its nose and then whiskers. And so here we have cation. And also you could think about cation, the word has a T in the middle, which looks like a plus sign, and again, it's positive. So cations are going to be typically metals. So they are positive. They will have less electrons than protons because they've lost electrons. Also, if we look at, I'll make this a little bit bigger, anions are going to be typically nonmetals. These are going to be negative. They're going to have more electrons than protons because they have gained electrons. And again, the word anion has N in it, N for negative. You can also think about an ant with a really sad looking face. And so that's just some different ways to remember that anions are negative, cations are going to be positive. Okay, so I want to bring up your periodic table to show you some different patterns with the charges and also review where the metals and nonmetals are. So I'm going to erase what I wrote on this previously. And on your periodic table, I want you to label some different regions on your periodic tables. So after I erase this, I'm also going to make this a little bit not as big, not as blown up. And okay, so on your periodic table, I want you to kind of look at this staircase here in the middle. And on the left of your staircase are going to be the metals. And on the right are the nonmetals. Okay, in the middle here are going to be the metalloids. So I'm actually going to highlight the metalloids. They're going to be all the elements above and below the staircase, with the exception of aluminum. And your book has polonium as a metal. So anything to the left of the staircase is a metal. Anything to the right, this little triangle here, is a non-metal. Anything on the staircase is a metalloid. So let me also just label metalloids. Okay, so I also want to put down the common charges. So the first group on the periodic table, excuse me about that, is +1. Hydrogen, though, is going to be plus or -1. The second group on your periodic table is +2. The 13th group is +3. The 14th group is plus or -4. Group 15 is -3. Group 16 is -2. 17 is -1. And group 18 is 0. These are talking about the common ions of these particular elements. So when we find them in nature, what we see is that group 1 typically forms a +1 ion. We don't see it as any other charge in nature, with the exception of hydrogen. Group 2 is going to be +2 when we find it in nature. Group 13 is going to be +3. Group 14 is plus or -4. Group 15 is going to be -3. Group 16 is -2. Group 17 is -1. And if we look at group 18, those are called the noble gases. Those typically do not form compounds, so we don't consider them as having a charge when we find them. Okay, so just be familiar with these patterns, these typical ions. Make sure you know these for the test and also for your quiz. Okay, so I want to go over now how to figure out the number of protons, neutrons, and electrons for ions. So we have here the symbol for an ion. So if we look at it, the mass number is typically written, A is typically written on the as a superscript on the left-hand side, and Z is typically written as a subscript on the left-hand side. So remember, this is going to be, and I'll label this. This is your A, and this is your Z. The charge is written as a superscript on the right-hand side if you have an ion. If you do not see a charge, you can assume it's a charge of 0. So let me go to the next slide. So here, if we look at this particular element, here we have sodium. We would see sodium because it has as Z is 11, has 11 protons. The neutrons would be the difference between 23 and 11. So that would be 12 neutrons. It's positive, so it's going to be kind of counterintuitive. We're going to be subtracting 1 from 11 to get our electrons. So that'll be 10 electrons. Its atomic number is 11. Its mass number is 23. Okay, so I also want to go over a negative ion, an anion. So if we look at our periodic table, I'm going to look at oxygen. Oxygen typically has a charge of -2. So I'm going to have a superscript of -2 on the right-hand side for the charge. The mass number we're assuming is 16, and the atomic number is 8. So if we calculate our number of protons, we do that according to our atomic number. So our protons are going to be 8. Our neutrons, we're going to take the difference between our mass number and our atomic number to get 8. Our electrons, is counterintuitive once again. We're going to add the absolute value of the charge to our atomic number to get 10 electrons. Now, the mass number A is going to be 16, and our atomic number Z is going to be 8. Okay, so always when you have an anion, you add the absolute value of the charge. When you have a cation, you subtract the absolute value of the charge. Now what I would like to do is to go over a few problems that are on your ion sheet so that you guys can kind of see how to work those. So let me pull that up. This is on Google Classroom. On the top here, what you're doing is you're trying to figure out how many electrons each of these have. So you're going to have to look at your periodic table. Aluminum has an atomic number of 13. It's positive. So we're going to do 13 minus the absolute value of the charge. That's going to give us 10. So that means our answer is going to be B for 10. And these are used more than once in some cases, the column on the right. We go down. I want to show you with these. Again, it's giving you the charge. So you have to use your periodic table to figure out your number of protons. Cobalt has 27 protons. It's positive, so we're going to subtract 2 to get 25 electrons. We're going to do those. Down here, you're going to use your periodic table. And if you look at number 53 is iodine. Iodine is in group, I'm going to pull up your periodic table. Iodine is in group 17, so it has a -1 charge. So we're going to just write down -1. So we're just writing the formula for the ion. Do the same for the others using your periodic table and knowing the common ions that are formed. On the next page, you're going to have to use your periodic table. Element with 12 protons is going to be magnesium. If it has 10 electrons, it means it has fewer electrons than protons. So it's going to be +2 charge. That's what you do for 4 through 8. Down here, you're going to use your atomic number to figure out your protons. Your mass number is going to be the difference between your protons and your number of neutrons will be the difference between your mass number and your atomic number. So that's going to be 31. Since it's positive, you're going to subtract 2 from your atomic number to get 26 electrons. That's what you do for 9 through 13. For number 14, you're going to have to use your periodic table. Number 84 is polonium. It has 84 protons, so we put 84 here. We add our protons and our neutrons to get our mass number. That's going to be 209. And then since we have fewer electrons than protons, it's going to be +4. We do the same thing for all the way up through 17. So that's how to do your ion worksheet. So good luck, and I'm going to have another screencast up today for your isotopes. So work on your ion worksheet, your atomic structure worksheet, and then after you finish those, watch a screencast for the isotopes, then do your isotope notation worksheet.